right, this is Precalculus Chapter 8 review. I'm on page 564. And these are the problems I'll be working. So 1 through 5, the instructions are solve them graphically. So I'm always going to set it equal to 0. For the first one, make sure your calculator's on radians. And I'm graphing for number 1, 5 times the tan of x minus 2 times the sine of 2x. And then I'm going to decide what my window is going to look like. I choose my largest period. The period for the tan is just pi. The period for the sine is 2 pi, but the b value is 2. So this is also going to be pi. All right, so when I graph it, I've already graphed this one. This is what it looks like. And I made my window 0 to pi. Well, it's got to intersect at 0. It's got to intersect at pi. I'm just going to enlarge my window a little bit. I'll go from like negative 0.5 to pi is 3.14. I'll go to 3.5 and just look at it. See, that's what it looks like. It's at 0. So it's every pi. So it's just k pi. All right, so it's 0 plus k pi is going to be x, or you just put k pi. All right, number 3. So for number 3, here's how I will graph it. It's going to be the sine of x plus 1 divided by, so you can't put the secant in there. You got to put the cosine. 1 over the cosine x, and I'm going to square that, and I'm going to subtract 3. All right, so that's what I'm going to put in my calculator, and I'm going to look between 0 and 2 pi. All right, so let me go put that real quickly. I should have put all of these in first. All right, sine x plus 1 divided by, gotta make sure I have all my cosine x, close, squared, close, minus 3. I'm gonna make my window 0 to 2 pi. And look what this looks like. Looks like they repeat. But I'm going to then do second trace 0 and find those solutions. I'm not going to do that, but you can do that, okay? I believe you can do that. All right, number 5. Number 5, I'm also going to set equal to 0 and look at a distance of 2 pi. So it'll be cosine 2x minus sine x. That's what I'm going to put in y1. You cannot play with that. My largest period is pi. So I will put that in my calculator. And I'm going to look at a distance of 2 pi. Let me just do that real quick. All right. Cosine 2x minus sine x. And I'm going to do pi. No, sir. Okay. My Cody. This is what it looks like. You're going to do second trace 0. Find all of the solutions. All right? So that's what you know. No. You cannot play with that. All right, let me get in my ball. All right, the next one is number 13. Just a minute. Mom's going to get your ball out of here. All right. The next one is number 13. Now you're going to hear squeaking because Cody wants something he can't have. All right, 13. Solve. So 13 and 15 solve without a calculator. All right, so 13 is inverse tan cosine 7 pi over 2. All right, I have to solve this first. All right, that's at the half pi. So I got to figure out how many times it goes around. So 7 pi over 2. One whole way around will be 4 pi over 2. So I'm looking for a coterminal angle in the first quadrant because that's where I'll know where it is. So it's 3 pi over 2. That's here. That's 3 pi over 2 on the unit circle, right? Cosine starts at 1, 0, negative 1, 0. So this is 0. And where is, now we're going to look at the tan. Inverse tan of 0. So now we're looking for radians. Inverse tan, just making sure I'm right, 1, 0, negative 1, 0. Yeah. All right. Now, well, for inverse tan, we're going to be between negative pi over 2 and pi over 2. The only way that the tan can be 0 is if the sine is 0. The cosine cannot be 0, all right? So really I'm looking for where the sine is 0 because tan is sine over cosine. Well, the sine starts at 0, so it has to be at 0 for 13. All right, because the sine starts 0, goes up to 1, 0, down to negative 1. All right, that's 13, 15. Is inverse cosine of 2. All right, 2, okay, we're in radians. I have to make sure I'm back in radians, all right? I am in this calculator. All right, 2 is not on the unit circle. So I'm gonna actually do cosine 2. And that's, is that it between quadrants 1 and 2? I bet the answer is gonna be 2. Because when we do the inverse for the cosine, we're in quadrants 1 and quadrant 2. So as long as these radians are in quadrant 1 and 2, I'm going to get the same answer. All right? I mean, we'll do it in my calculator. I can do the whole thing. I'll just show you. But I'm expecting it to be 2. Look, just did in my calculator. So I didn't need a calculator. It said not to use calculator. But I knew that it would be 2 because of the quadrant. All right. Number 35. Okay, let me read the instructions. Find exact solutions when you can. Okay, so 35. Secant squared x plus 3 tan squared x equals 13. So I'm going to use an identity. The secant squared is 1 plus this tan squared x. I'm going to subtract 13 and set it equal to 0. I'll combine my like terms. So we have 4 tan squared x minus 12 equals 0. I'm going to divide it I'm just going to go ahead and solve this for tan squared x. All right, I'm going to move the 12 to the other side. 4 tan squared x is 12. I'm going to divide by 4. Tan squared x is 12 fourths. Take the square root. tan x is what? 2 square root of 3 over 2, which is just the square root of 3. All right, so that's the sine over the cosine. Okay, I'm going to see that as square root of 3 over 1, which is the same thing as a square root of 3 over 2 over 1/2. That has to be the sine. So I want an exact solution. So we're going to be, does it say every solution? Let me go back and look. All right, we can give an exact solution. All right, so the sine is the square root of 3 over 2 at pi over 3. All right, so x is pi over 3. If it wants all solutions, you're just going to do plus k pi, because the period of the tan, let me see what it gives you. The period of the tan, yeah, is k pi. You don't have to do plus and minus because this covers everything. All right, your book did plus and minus. All right, 37. Looks like a quadratic. All right, 2 sine squared x plus sine x minus 2 equals 0. I'm going to just use the quadratic. So x equals the opposite of b plus minus the square root of b squared minus 4 times a times c all over 2 times a. So x is negative 1/4 plus minus 4 times 4 is 16, square root of 17 over 4. That's what x equals. So I would get that in a decimal. Do it in this calculator. I'm going to do plus and minus. It's really going to be the sine of x equals plus and minus. So I'm going to have, all right, I'm just going to do it. Negative 1/4 plus, I'm just double checking, that's 17. Square root of 17 over 4. So plus I get 0.7808 and minus I get negative 1.2808. Okay, that's not going to be a solution because the sine of x can't be greater than 1 less than, okay. So now we have sine x is 0.7808, and now I just do inverse. Sine inverse 0.7808. Oh, I'm in degrees. Let me go to this calculator, make sure I'm in radians. I immediately knew I was in degrees. All right, shift sine 0.7808. It's too big a number. All right, so x equals 0.8959. And I bet they give you one more because you have to remember. So it's plus 2k pi. Because the sine of x also equals the sine of pi minus x. So I bet if I do pi minus that, I'm going to do that second pi minus that answer. And I get 2.24. So x equals 2.2456 plus 2k pi. All right, that was 37. I'm going to cross these out so I know where I am. Now we're going to 39, problem 39. All right, problem 39 references you back to a formula from a previous lesson. I wrote it down. Distance equals velocity squared over 32, I believe, times the sine of 2 theta. I'm just double checking. All right. All right, so you just have to plug the numbers. This is the plug and chug. A cannon has a muzzle velocity. That's the velocity. At what angle? So we're solving for the angle. At what angle should it be fired to hit a target? That's the distance, 3,500 feet, or whatever the distance is. All right. So then I'm going to multiply by the reciprocal of this. So 32 over 600 squared. 32 over 600 squared. This eliminates 32 times 3,500 divided by, that is Cody playing with his toy. So it's 0.31 repeat equals a sine of 2 theta. I'm just going to see that as u. And I'm going to solve for u. So I'm going to do the inverse sine of 0.31 repeat equals u. Then I'm going to go back and put 2 in. I bet it also gives us 2 angles. Okay. Shift sine. I'm going to just pop in that answer. All right. So I get, let me just make sure. Wait, it's theta. It has to be degrees. All right, so I'm gonna use my other calculator. This one's in degrees. All right, shift sine 0.31 repeat. All right, so u equals 18.13, but that's really 2 theta equals 18.13. So divided by 2, it's 9.06 degrees. All right, so the sine of theta is going to equal the sine of 180 minus theta, since we're in degrees. So I'm going to take 180 minus 18, 180 minus 18.13. And that's going to give me a u value of 161.87, but that's really 2 theta equals 161.87. So I divide it by 2, and theta is 80.94 degrees. All right. Now 41 is definitely hard. All right, but doable. I don't know if I can draw this image. The paddle of a wheel of a steamboat. So I'm going to draw the wheel. Has a diameter, I'm going to do the radius, of 11, right? All right, so that tells me the amplitude is going to go up 11. So the amplitude is 11. And it's turning at 3 revolutions per minute. The axle of the wheel is 8 feet above the surface of the water. So all of this is like 8 feet. So here's the axle. So it's 8 feet. There's some distance, 8 feet above, and here's the water. All right. I guess that's okay. All right, the maximum height above the water. What's the maximum height above the water? This is A. So above the maximum height is going to be 8 feet and 11 more. So that's 19 feet. Okay, supposing this thing rolls around and around, you know, maybe there's something here and it's going to roll it around, down, and around. So how far below the water is it going to get? It's got to be 11 minus 8. What is that? 3 feet? 3. Oh, look, I did inches here. 3 feet below the water. All right, that's B. We're just going to go through D. In how many seconds does the wheel complete one revolution? All right, so this is C. We have 3 revolutions per minute, but it wants to know for seconds. All right, so I have to use the unit multiplier. And 1 minute is 60 seconds. So when I simplify this, I end up with 1 revolution per 20 seconds. So it completes a revolution in 20 seconds. Is that? Yeah, 20 seconds. So write the cosine function. This 20 seconds, that's the period. All right? Time is your period. All the way around the wheel, the distance is 2 pi. All right? So I need to find my my B value. All right? So we do 20 equals 2 pi over B. 20 equals 2 pi over B. I swap my extremes. B is 2 pi over 20, which is pi over 10. Now I have my B value, all right? Now it wants us to write a cosine function. I have the amplitude. This is a vertical shift up by 8 feet. So assume the center of the wheel is at the origin. On the edge of the paddle wheel is at 0.19. So it's going to be a sine. Write a cosine. All right. So if I write a cosine, this is D, right? My amplitude is 11. Cosine, my B value is pi over 10. So pi over 10 times T. But I vertically shifted it up by 8. All right?